All right, the next thing we need to know and understand is the yearly cycle, the cycle that takes place every year as the Earth goes around the Sun. So we're going to study the yearly cycle. This happens every year as the Earth orbits the Sun. Earth orbits the Sun. And so the question I love to kick this off with, the question I love to ask students is, I say now, why is it that it is warmer in June and it's colder in December? Why is that? What's the cause of that? Somebody thinks for a minute, and usually somebody says, well, the reason it's warmer in June and colder in December is in June, we're closer to the sun. The sun, the source of all warmth and heat and light. And oh, in December, it's cold in December because we're farther from the sun. That's the explanation. We're closer to the sun in June, farther from the sun in December. I love it when somebody answers that because it's wrong. It's totally 100% utterly, completely wrong in every possible way. No, we are not closer to the sun in June and we are not farther from the sun in December. And I mean that very, very literally. If you personally were to take a tape measure and measure the distance from your nose to the sun on noon on a day in June, measure that distance, and then 6 months later in December at noon, measure the distance from your nose to the sun, you would find that you personally are closer to the sun in December and farther from the sun in June. And the actual difference in distance is tiny, it's trivial, and it's not a major factor in the seasons at all. It's not about distance from the sun. We hold relatively a fairly constant distance from the sun. It's not about distance from the sun. So I say that and then ask people to think a little bit, and then somebody remembers their 5th grade science lesson and says, no, it's about the tilt. It's about the tilt. Okay, so the Earth is tilted on its axis by 23.5 degrees. And so here's the Earth's North Pole pointing up, the North Pole pointing up toward Polaris. And it's tilted away from, straight up vertical by 23.5 degrees. And so here's the sun. And so here's what happens. Since we're here, the northern hemisphere gets summer because we're tilted toward the sun. The southern hemisphere gets winter because they're tilted away from the sun. So this is summer for us. And then as the Earth moves in its big yearly cycle around the sun, from above the North Pole, from above the Earth's northern hemisphere, it moves counterclockwise. So when it's over here, it's still pointed the same direction. That North Pole is always pointed exactly at Polaris, but now since we're on the other side of the sun, that North Pole is still pointed in exactly the same direction at Polaris, way off in that direction. Then what happens is now we're tilted away from the sun, so here is winter for us. Now this is true, it is accurate, it is right, and I want you to know more than just this, because this is the out in space view, looking down on the solar system view, seeing things from very far away. And of course, this sort of knowledge, this was the view of things which only came relatively recently in the last few hundred years with the scientific revolution. And yet before that, everybody all around the world understood the seasons. They understood the seasons and why it was warm in the summer and cold in the winter. They didn't know this, but they had another explanation, which was also true. So I want you to understand that. Not just, okay, the space eye view, the modern current view, but how about a horizon-centered view? The question now is, how does the sun move through the sky? If I don't know all the details about space and the sun and the Earth moving and all this sort of thing, I can still understand why it's warm in the summer and cold in the winter and give an answer that it's true. But now my answer has to do with, well, the sun moves through the sky in different ways at different times of year. So, how does the sun move through the sky differently at different times of year? Now ask yourself that question. I ask that question in class, and usually somebody can come up with, in summer the sun comes higher up in the sky, and in winter the sun is lower in the sky. I'm facing south here, so down if I look toward the south, this is the south is where the sun is highest in the sky at each day. But in winter it comes up very low in the sky. During summer it's much higher in the sky. And that's another true, accurate reason for the seasons. When the sun is relatively high in the sky, the sun is never directly overhead. The sun never reaches the zenith here in the United States. You've got to go to the tropics for that. But when the sun is higher in in the sky, the sunlight is more intense. It's not spread out over the surface as much. But man, when the sun is low in the sky, the sunlight comes in at an angle, and then it's a little ray. Imagine a ray of sunlight. It gets spread out very broadly over a huge patch of ground. So the amount of energy per square foot received from the sun is relatively small when at noon on a winter day. But at noon on a summer day, it's not spread out as much. Doesn't come in an angle. It comes more or less closer to straight down to the ground. So it delivers more energy per square foot. So there's another true, accurate explanation for why it's warm in the summer and cold in the winter. So how does the sun move? Well, okay, so here's a key idea. It goes at noon. At noon, it is higher in summer and lower in winter. So that's another good, true, accurate explanation. And that's the explanation that if you ask somebody 1,000 years ago, why is it warm in the summer and cold in the winter? That's what they have said. Well, it has to do with the height of the sun in the sky. Also, a true explanation. All right, so now we need to understand some of the key days throughout the year. Let's start with the equinoxes. Equinoxes. There are 2 equinoxes every year. The equinoxes fall on, in our calendar, roughly March 21st and September 21st. Could be the 20th, could be the 22nd. It varies a little bit with our calendar and leap years and stuff like that. But roughly right around March 21st, September 21st, we have the equinoxes. Equinox. Equal, nox, Latin meaning night. Equal day and night. These are the 2 days throughout the year where you have exactly 12 hours of daylight and 12 hours of darkness. 12 hours of daylight, 12 hours of darkness. These are the 2 days throughout the year where the sun rises exactly perfectly due east, so it's 90 degrees from Polaris. Therefore, it comes up in the sky and roughly 45 degrees from the horizon in the United States and sets exactly due west. The sun rises due east, sets due west. So that's why we have these special days, these equinoxes, equal day and night. The sun rises exactly due east, sets exactly due west, 12 hours of daylight, 12 hours of darkness, everything is balanced. March 21st and September 21st. Now let's do the solstices. Let's do the summer solstice. Solstice, sol meaning sun, stis meaning stop. Where the sun stops. The summer solstice, this, on the other hand, is right around June 21st, 20th, 21st, 22nd, something like that. The summer solstice, June 21st. Now, this is the longest day of the year, and therefore the shortest night. I mean, a day still lasts 24 hours, but you have longest daylight, shortest dark time. So, longest day, period of the time in daylight, shortest night, and so then the question, well, where does the sun do? If we have the longest possible day, this is the day where the sun is at noon. Sun is highest in the sky. The sun is never directly overhead, never at the zenith here in the United States. But where does the sun rise? How does it get higher in the sky? Well, if it rises due east, it's going to come over here. So that means its angle to Polaris, if it's even higher in the sky, the angle to Polaris must be an acute angle, less than 90 degrees. If it's less than 90 degrees, where is it going to? Oh, if it's less than 90 degrees, well, it can't rise over here directly due east. That would make it 90 degrees. It must rise north of east. The sun rises on the summer solstice, and shoot, any time in the spring, summer months, the sun rises north of east, comes very high in the sky, and sets north of west. Sun rises north of east, the sun sets north of west. The sun rises north of east, it sets north of west, and so its angle to Polaris is acute, is less than 90 degrees. And so then that's why it's warm in the summer. It comes higher up in the sky, its energy is more delivered more directly to the ground, more energy per square foot. That is the summer solstice. Let's do the winter solstice. So we have these 4 special days which divide the year. The 2 equinoxes, the 2 solstices. The winter solstice is, well, this one is in December 21st. So on December 21st, the winter solstice, now this is the day out of the year. This is where we have the shortest day, the longest night. Shortest longest day. We have the longest night. This is the day where the noontime sun is lowest in the sky. So, oh, that angle there's Polaris, 45 degrees, whatever. Okay, it's low in the sky. So now the angle between the North Star and the sun is an obtuse angle, more than 90 degrees. So the noon sun is lowest in the sky. So where would that sun rise and set? If it's December, where does the sun rise? It doesn't rise due east. If that angle is obtuse, that means that, well, it must rise. Can't rise over here. It must be farther away from Polaris. This is where the sun rises south of east, comes low in the sky, sets south of west. And the solstice is the day where it rises farthest south of east. So the sun rises south of east, sets south of west. And so then this explains why it gets cold. The sun rises south of east, low in the sky, south of west, and then throughout the year, on the equinoxes, it rises north of east, and then during the spring and summer months, it swings over, it rises due east on the equinoxes, rises north of east during the spring and summer. The summer solstice is farthest north of east, then it swings back like a pendulum, rises due east on the fall equinox, September 21st, then rises south of east, farther south until December 21st, where it rises farthest south of east, and then swings back to the next spring equinox, and so it kind of swings back and forth like a pendulum on the horizon, swings back and forth. The noontime sun swings back and forth in the sky to being more overhead, less overhead, and that explains the seasons. And now we have a good explanation, either both the space-based, very, from out in space view sort of thing, as well as this horizon view. And together, that gives us a solid understanding of why we have the seasons as they do. And as the sun is moving, rising and setting in these different places, it's moving through different stars. So now I want to compare this motion of the sun. Well, of course, it's really the Earth that's moving, but as the Earth moves around the sun, well, we see different stars behind the sun. So the sun, throughout the year, the sun appears to move through the stars. So it appears to move through the different stars and through the different constellations. It moves in one big circle through the stars once every year. 365 days in a year, so it moves about 360 degrees in a circle. It moves about 1 degree a day. That's not a coincidence. That was come up with by the Babylonians. About 1 degree each day. 360 degrees in a circle, so 1 degree in each day doesn't very move. And its path through the stars, its path through the constellations is called the ecliptic path. And this is also the path that pretty much the moon moves and the planets move and those sorts of things. So the things in our solar system, most of them move pretty close to the sun's path. So the sun's path through the stars is called the ecliptic. And the constellations it goes through, these constellations are called the constellations of the zodiac. Constellations goes through are called the constellations of the zodiac. So that's how astrology and stuff like that got started. It's all superstition and a bunch of hooey. But the truth is, the sun does appears to go through these different constellations, and it makes a circle through all these constellations every year. Excellent.